Light. Lesson preview. Rectilinear propagation of light. Reflection of light. Plane and spherical mirrors. Formation of images in a concave mirror. Uses of a concave mirror. Formation of images in a convex mirror. Uses of a convex mirror. Terms related to spherical mirrors. Lenses. Terms related to lenses. Sunlight white or colored. Newton disk. We have already learnt that light is a form of energy. We cannot see anything without light. When you see the beam of light either from a torch or that coming from the headlights of a car, you notice that light appears to travel in a straight line. Rectilinear propagation of light. In the previous class, you had performed an activity to show this. You first observed the flame of a candle through a straight straw and then through a bent straw. If you recall, you were not able to see the flame with the bent straw. This activity shows that light travels in straight lines. This property of light is called rectilinear propagation of light. Straight straw. Bent straw. Reflection of light. When light falls on a polished surface, such as a mirror, still clear water, or a shining stainless steel plate, some of it is absorbed and some bounces back. We know that light travels in a straight line, but we can change the direction of light by reflection. The surface of water also acts like a mirror and it can change the direction or the path of light. You must have noticed the reflection of trees, buildings, etc. in water. The change in the direction of light by a mirror is called reflection of light. Plane mirrors. Activity. Place a lighted candle in front of a plane mirror. Try to see the candle in the mirror. It appears that a similar candle is placed behind the mirror. The candle is called the object and the copy of the object in the mirror is called its image. Now move the candle to a different position in front of the mirror. Observe the change in the position of the image. Now place a vertical screen, a sheet of white paper, behind the mirror, and try to obtain the image of the candle on it. Next bring the white sheet in front of the mirror. Can you see the image of the candle now? It is seen that when the candle is kept 8 cm from the mirror, its image also seems to be 8 cm behind the mirror. The image formed is upright in each case. The top and bottom of the image is same as the top and bottom of the object. Such an image is called erect. You cannot touch the image obtained on the mirror as the image appears to be behind the mirror. Such an image is called a virtual image. The size of the image of the candle is the same as the size of the candle. The image of the candle cannot be obtained on the white sheet of paper in both the cases. Thus, it is seen that an image formed by a plane mirror is erect, is virtual, i.e. it cannot be obtained on a screen, appears to be at the same distance from the mirror as the object is in front of it, appears to be formed behind the mirror. Activity. Stand in front of the mirror. Hold your left ear with the left hand. Which ear does your hand hold in your image? Observe carefully. You will see the right hand touching the right ear. In the mirror, the right appears left and the left appears right. Now write a few words on a piece of paper and hold it in front of the mirror. Thus, it is seen that images formed on a plane mirror interchange sides only. However, the image does not appear upside down. This interchange of sides, i.e. from left to right and vice versa between the object and its image is called lateral inversion. Now you will be able to understand why ambulance is written in an inverted manner on an ambulance van. When the driver of a vehicle in front of the van looks in the rearview mirror of the vehicle, he or she will read it as ambulance, and will then allow the ambulance to go ahead by making way for it. Plane mirrors have many uses as looking glasses, periscopes, kaleidoscopes, solar cookers as a reflector, spherical mirrors. Let us study the characteristics of images formed by spherical mirrors. Spherical mirrors are mirrors with a curved surface. Activity. Take a shiny stainless steel spoon. Look at your reflection in it both on the outer side of the spoon as well as on its inner surface. Do you see your image on it? Is the image different from what you see in the plain mirror? The stainless steel spoon serves as a spherical mirror. It has two types of reflecting surfaces, one that bulges out to form a convex surface, and one that curves inwards to form a concave surface. On the concave side of the spoon, inside of the spoon, your image formed will be erect and larger in size. If you increase the distance of the spoon from your face, the image will be inverted. Whereas, on the convex side of the spoon, outside of the spoon, the image formed will always be erect. Outer side, inner side, concave mirror, convex mirror. Concave and convex mirrors are called spherical mirrors because they are a part of a hollow sphere. To understand this better, take a coconut which has been cut into a half. The inner surface of the cut coconut is called concave, and the outer surface is called convex. Some common examples of curved mirrors are spoons, ladles, shaving mirrors, car mirrors, etc. Formation of images in a concave mirror. Activity. Fix a concave mirror on a stand and place it on a table. Place a white sheet of paper in front of it. This will act as a screen. It would be better if the paper is pasted on a cardboard sheet. Place a lighted candle at a distance of about 50 centimeters from the mirror. Try to get the image of the flame on the screen by changing the position of the screen. What kind of image is formed? Move the lighted candle closer towards the mirror at different distances. Again adjust the white screen to obtain the image of the candle flame on it. What do you observe? Record your observations in the tabular form. When the candle is placed very near to a concave mirror, a virtual image is formed behind the mirror. The image is erect and magnified. In other cases, a real, inverted image is formed and the image is smaller than the size of the object. Size of the image increases as the lighted candle is brought closer to the mirror. Image formed by a concave mirror for objects placed at different distances from it. Thus, it is seen that image formed by a concave mirror may be smaller or larger than the object. It can also be real or virtual. As the distance of the object from the concave mirror increases, the size of the image decreases. Uses of a concave mirror. Concave mirrors are used in headlights of vehicles, torches, searchlights, etc. They are used by doctors for examining eyes, ears, nose, and throat. They are used by dentists to see an enlarged image of the teeth. They are used as shaving mirrors and makeup mirrors to see an enlarged erect image of the face. They are used in reflector-type telescopes. Shaving mirror. Telescope. Formation of images in a convex mirror. Activity. Repeat the activity 4, using a convex mirror instead of a concave mirror. Record your observations in a table similar to the one used in activity 4. What do you notice? The image formed by a convex mirror is always virtual, erect, and smaller than the object, irrespective of the position of the object from the mirror. Uses of a convex mirror. Convex mirrors are used as rear-view or side-view mirrors in vehicles. They view a large area, much wider than that of a plain mirror. They help the driver to see the traffic coming from behind. They are used in shops and malls for surveillance. Table. Nature of image formed by different types of mirrors. Nature of image formed. Mirror. Real/virtual. Erect/inverted. Size. Plain. Virtual. Erect. Same size as that of the object. Concave. Real except when the object is very close to the mirror, then image formed is virtual. Inverted when real. Erect when virtual. Depending on the position of the object from the mirror, it could be diminished, enlarged, or of the same size as the object. Convex, virtual, erect, always diminished. Terms related to spherical mirrors. Concave mirror, convex mirror. The center of the mirror is called its pole, P. The center of the sphere of which the mirror forms a part is called its center of curvature, C. The line passing through the center of curvature of the mirror and the pole is called its principal axis. It is always perpendicular to the mirror. The point at which all rays falling on the converging, concave, mirror parallel to its principal axis meet or seem to meet, converge, is called its principal focus, F. Convex mirror, concave mirror. Lenses. A lens is a piece of any transparent material which has two surfaces, with either one or both being spherical. Lenses are used in cameras, telescopes, microscopes, and spectacles. The magnifying glass which you must have used to observe very small objects is also a type of lens. There are two basic types of lenses, convex lens and concave lens. A convex lens is thicker in the middle than at the edges, whereas a concave lens is thinner in the middle than at the edges. Since lenses are transparent, light can pass through them. A convex lens. A concave lens. Activity. Take a magnifying lens, convex lens, and adjust its position in such a way that you are able to see a bright spot on the white sheet of paper placed in bright sunlight. The spot is the image of the sun. Hold the lens in the same position for some time. What do you see? The piece of paper will start burning. Now repeat the same experiment with a concave lens. You will not be able to see any bright spot on the paper, real image. The convex lens forms a sharp image of a far-off object, whereas a concave lens does not form a sharp image. It forms a virtual image. Activity. Formation of images by a convex lens. Take a convex lens and fix it on a stand. Place it on a table. Now place a lighted candle at a distance of 50 centimeters from it. Place a white sheet of paper, screen, on the other side of the lens. Move the screen forward or backward so as to get a sharp image of the flame. What kind of image is seen? You will see an image that is real, inverted and smaller than the object. Now bring the candle closer to the lens and again observe. The image now formed will be real, inverted and larger in size than the object. Bring the candle even closer to the lens. What do you observe? The image formed is virtual, erect and magnified. Real, inverted and diminished image. Real, inverted and magnified image. Activity. Formation of images by a concave lens. Now repeat the activity 7 with a concave lens. Do you notice any difference in the image formed? The images formed by a concave lens are erect, virtual and diminished for all positions of the object. A convex lens is also called a converging lens as it converges, bends inwards, the light falling on it. A concave lens on the other hand diverges, spreads outwards, the light falling on it, and is thus called a diverging lens. Convex lens. Concave lens. Differences between a convex lens and a concave lens. Convex lens. It is thicker in the middle and thinner at the edges. It is a converging lens. It forms real and inverted images for all distances, except when the object is placed very close to the lens, then it forms a virtual, erect and magnified image. Concave lens. It is thinner in the middle and thicker at the edges. It is a diverging lens. It always forms a virtual, erect image, smaller in size than that of the object. Terms related to lenses. Principal axis. It is the line joining the centers of the two spheres C1 C2 of which the lens forms a part. Convex lens. Concave lens. Optical center. It is the center of the lens. O. A light ray passing through the optical center of a lens remains undeviated. Principal focus and focal length. A converging lens bends a light ray passing through it inwards towards the principal axis. It makes all the parallel rays to the principal axis to meet, converge, at a single point. This point is called the principal focus of the lens. F. A concave lens has the property of bending a light ray passing through it outwards. The light rays parallel to the principal axis spread outwards or diverge. If extended backwards, the rays of light appear to meet at the principal focus. Convex lens. Concave lens. The distance between the optical center of a lens and its principal focus is called the focal length of the lens. In the figures above, of is the focal length. Sunlight, white or colored. Have you seen a rainbow? It usually appears after the rain when the sun is low in the sky. How many colors does it have? A rainbow is made up of 7 colors: violet, indigo, blue, green, yellow, orange, and red. Vidgayor. If you take a CD, compact disc, out in the sun, you will see many colors when light is reflected from the CD. The colors actually come from the sunlight. Rainbow. A CD placed in the sun. Activity. Take a glass prism. Allow a narrow beam of white light, sunlight, to fall on one face of the prism. Place a white sheet of paper on the other side of the prism. What do you observe? You will see a band of 7 colors, similar to those seen in a rainbow. This shows that white light consists of 7 colors. The process of splitting white light into a band of 7 colors is called dispersion of light. The 7 colors formed due to the splitting of white light is called spectrum of white light. Newton disk. Newton disk is a colored disk painted with the 7 colors of the rainbow in equal sections. When the disk is rotated very fast, the colors disappear and the disk appears white. This is because the colors get mixed together. Activity. To make a colored disk, take a circular piece of cardboard. Divide it into 7 segments. Paint each segment in 7 colors of the rainbow in the order of Vidgayor. Make a small hole in the center of the disk, and fix the disk on a stick loosely. Rotate the disk quickly in sunlight. The disk will appear white. Disk with 7 colors of rainbow. Disk appears white on rotation.